show how to find a monotone likelihood ratio for a Bernoulli distribution. We have unknown parameter p, and we have defined the statistic y as the sum of all x's. We have also found two values in the parameter space, p1, p2, any arbitrary values, but p1 has to be less than p2. To see a monotone likelihood ratio, we have to stack two likelihoods on top of each other. One is a function of one of the parameters we picked, and then the other. We put the smaller parameter on the denominator of this ratio, or the downstairs. Then we put in our likelihood function. Since we have a set of n values that are all Bernoulli, this is the product of the Bernoulli PDF. So I have p2 to the power of xi, 1 minus p2, 1 to the power of 1 minus xi. The denominator is the same thing, except we use p1. 1 minus p1, 1 minus xi. Then we can do some simplifying steps, just using some rules for exponents. And using my definition of y, I have 1 minus p2 over 1 minus p1. All of that is to the power of n minus y. A little bit more rearrangement, and I have p2, 1 minus p1 over p1, 1 minus p2. All of this to the power of y, and then times 1 minus p2 over 1 minus p1, and that is to the power of n. Now I'm going to be checking to see if this ratio of likelihoods is an increasing or decreasing function as a function of y, or some statistic. In this case, it's y. Now, one thing that I notice is that this term over here has nothing that involves y in it, so I don't have to worry about that term at all when I'm trying to assess if it's increasing or decreasing. So I can do another step, which is proportional to, which only has the components of the statistic that I'm interested in, which is y. So I have p2, 1 minus p1 over p1, 1 times 1 minus p2, all to the power of y. Now to determine whether or not, well, first off, this is a monotone likelihood ratio as a function of y. But to determine whether or not it is increasing or decreasing, I have to know whether or not the term inside of the square brackets is less than 1 or greater than 1. If it's less than 1, then a value that is less than 1, and we just take the power of that value, it's either going to get smaller and smaller and smaller as our power term gets bigger, or if it's greater than 1, it's going to get bigger and bigger as our power term gets bigger and bigger. So you might be able to tell right away whether or not this term inside the square brackets is less than 1 or greater than 1, but it's always good to slow down and do a quick gut check. So I'm going to check if it's increasing or decreasing. Let's say I'm not quite sure, or I just want to double check, and I'm specifically going to check if it's increasing. So I'm going to check if the term in the square brackets, I'm going to check if that term is greater than 1. And I don't know, so I'm going to put a little question mark so I can remind myself what I'm doing. I have p2, 1 minus p1, greater than p1, 1 minus p2, which gives me p2 minus p2, p1, p1 minus p1 times p2. This gives me p2 greater than p1, which was something that I started off with. So yes, this relationship holds. I have an increasing monotone likelihood ratio as a function of y. Now that's really nice for us, but sometimes it is nice to have a statistic which is a decreasing function. So it will give us a monotone likelihood ratio that is decreasing as a function of some other statistic. If we wanted to do that, we could just define a new statistic. Let's let t equal negative y. Then our likelihood function, p2, given the data, over p1, given our data, is still proportional to p2 over p1, 1 minus p1 over 1 minus p2, all to the power of negative 1 times negative 1, which is just 1, times y, which gives us P1 over P2, 1 minus P2, so everything's flipped, 1 minus P1, and so I'm put that power to the negative 1 inside my square brackets, flipped everything around, and then I have negative y up here. Negative y is just equal to t. And then doing a very similar check to what I did just over here, I will end up seeing that I have a decreasing monotone likelihood ratio as a function of t.